So in this lesson, we're going to look at the second half of how to graph rational functions. If you remember, in the first lesson, we learned how to find the vertical asymptotes and wholes, and that's based on the zeros, right, of the denominator. So refer to the previous lesson if you want to go back and review that. In this lesson, though, we are going to figure out how do we now identify the horizontal asymptote. And then we'll kind of put it all together and look at how we can sketch the graph, knowing what the vertical and horizontal asymptotes are, and use some tools like Desmos to help us do that. All right, now this is where it gets really tricky, but hang with me here. This page gives us the rules for what type of horizontal asymptote we're going to have. And there's three possible cases. At most, notice we're going to have one horizontal asymptote. So unlike vertical asymptotes, where there's really no limit to how many we can have, for horizontal asymptotes, we will have either 0, none, or 1. Okay, so if we do have one, the question is, where is that horizontal asymptote? So let's step through the cases. We'll go through some examples and you'll see how this works. So in case 1, we're comparing the degree. Now I'll talk about what the degree is here in a minute. The degree of q of x is greater than the degree of p of x. In other words, the degree of the denominator is greater than the degree of the numerator, then there is a single horizontal asymptote at y equals 0. So that's going to be right on the x-axis. Now, if it's the other way around, if the degree of p of x is greater than the degree of q of x, the degree of the numerator is greater than the key of the denominator, then there is no horizontal asymptote. Now, what happens if they have the same degree? So that's case 3. If the degree of p of x and q of x are equal, then we're going to have an asymptote, but we're going to have to calculate what that y value will be. It won't be at 0. And how we calculate that is we take the ratio of the coefficient of the highest degree term of p of x and divide it by the coefficient of the highest degree term of q of x. And again, we'll go through an example and this will make sense. So this list of properties in these three cases, along with the rules for the vertical asymptotes and wholes, I'll put that in a single summary sheet as a document saved in Google Classroom, so you can pull that up and refer to these easily. All right, now what do we mean by degree of polynomial? So it's the exponent of the term with the highest power. So let's look at some examples, right? Here's a quadratic expression, x squared plus 4x minus 7. So the highest power, right, is the x squared term. So the 2 would be the degree. This expression would have a degree of 2. How about 3x plus 6? Well, the highest power is actually x to the first, right? We don't put a 1 there, so this would have a degree of 1. Here's an expression, right? We have two binomial factors, and we could say, well, it must just be 1, but what if we multiply these together? The x times x is going to give us x squared, and then that would therefore have a degree of 2. Okay, so the degree will be the highest exponent, the term with the highest exponent, whatever that exponent is, that gives us the degree of the polynomial. All right, let's go through some examples here and see for each of these three cases what it looks like to find the horizontal asymptote. So here's our rational function, 3x minus 12 divided by x squared minus 4. So the first step is, what are the degrees of p of x and q of x? So p of x would have a degree of 1. We have 3x, that x is the highest degree of 1. And q of x is going to have a degree of 2. The x squared term, we're going to use the 2 in the exponent. All right, so let's pull up our sheet again, because this is not something that's going to be easy to memorize. So you got to keep this handy. So which case do we have if the degree of q of x is greater than the degree of p of x, right? 2 is greater than 1. Well, it's this first case right here, right? This is the case. And then it tells us that there is going to be a horizontal asymptote at y equals 0 on the x-axis. right? So let's just describe that. We'd say one horizontal asymptote at y equals 0. What would that look like on a graph? Well, it would be right there along the x-axis. All right, let's try another one. X squared minus 25 over x minus 4. Again, what are the degrees of p of x and q of x? So the numerator has a degree of 2. The denominator has a degree of 1. So again, which case are we looking at? This time, case 2, right? P of x degree is greater than q of x degree. Therefore, there will be no horizontal asymptote. Okay, so that's all we really have to state, right? It's just that there is no horizontal asymptote. All right, we've looked at case 1, case 2. Let's look at an example for case 3. So 3x plus 5 over x minus 2. Okay, and their degrees would both be 1 in this case, right? So that gives us case 3. If the degree of p of x and q of x are equal, then we're going to use this little formula to find the y value. And it's the ratio of the coefficient of the highest degree term. So it's those same terms we use to find the degree, but now we're going to say what are their coefficients. So what would that look like? Okay, let's go ahead and find our a value, right? The a value is going to be the coefficient of the highest degree term. So that is our 3. 3 is the coefficient. And for the denominator, the highest degree term is x. There is no coefficient, so that means it's just 1. Okay, so with simple ratio here, just gives us 3. That means we're going to have a horizontal asymptote at y equals 3. Okay, so there's the 3 cases, right? And it all starts with finding the degree of the asymptotes, or the numerator and the denominator. Horizontal asymptote at 3, there we go. It would be right there at positive 3, horizontal line, positive 3 on the y-axis. All right, let's try a couple more here. See if you can do this yourself. So pause the video and keep that little reference page handy you can pull up and see if you can figure out which case we have. So here we go. Degrees of 1 for p of x, degree of 2, right? Because if we multiply x times x plus 4, we're going to get an x squared term. So which case do we have? This is case 1 again. Q of x is greater than p of x. So we're going to have a horizontal asymptote at y equals 0. And again, that would be right on the x-axis. All right, let's try another one. Same thing, pause it, see if you can figure it out, and then confirm. All right, so p of x, degree of 2, if we distribute the 3x to what's inside the parentheses, we'll get an x squared term. And q of x, the degree is 1. So in this case, right, we have p of x greater than q of x. So in this case, there is no horizontal asymptote. So nothing to graph, at least for the asymptote. The graph, the function will still have a graph. All right, let's look at one more example of case 3 here. Go ahead and pause it and see if you can find the degrees. And then in this case, we're going to use that little formula, right? Y equals A over B. All right, the degrees here are going to be the same. They both have a degree of 2, right? So that's going to be case 3, which means we're going to use this formula, Y equals A over B. So again, where do A and B come from? They are the coefficients of the terms with the highest degree. So that means -4, right, for the A term, and +2 for the B term, which if we simplify, we get a -2. So we will have a horizontal asymptote at y equals -2. Where will that be on the graph? There we go, right through -2, horizontal line. And there's another example of case 3. All right. Now, what if we want to try and put all this together? Okay, so using not just this lesson, but the previous lesson on how to find the vertical asymptotes or holes, the horizontal asymptotes, sketch those on a graph, and then we're going to use Desmos to help confirm, right, what the branches look like. All right, so first, vertical asymptotes or holes. Remember, this is where we look at the zeros. So for p of x, we have a 0 of -3. If we put -3 in for x, it would make the numerator equal to 0. And for q of x, right, we have a zeros at 1 and 5. So neither of those are common to the -3. So both 1 and 5 will be vertical asymptotes. 1 at x equals 1, 1 at x equals 5. So let's sketch those on our graph here. Here's our vertical asymptotes at 1 and 5. All right, what about the horizontal asymptotes? This is where we're going to use what we just learned in this lesson. Right? So we have a degree of 1 for the numerator, and we have a degree of 2 for the denominator. Now, I'm not going to pull that set of cases up again, but hopefully by now you're familiar how to use that. This is where q of x is greater than p of x degree. So we're going to have a single horizontal asymptote at y equals 0. So that's going to go right there across the x-axis. All right, so we have our 2 vertical and 1 horizontal asymptote. So think back to the original lesson, right? How many branches will we have here? Well, we really have 2 points of discontinuity, right? 1 and 5. So if we have 2 places where we're going to have to lift our pen as we sketch those branches, that means we will have a total of 3 branches. And you can kind of picture that, right? We're going to have a branch to the left of the first vertical asymptote, and then a branch in between, and then a branch to the right. The question is, are those branches going to be above or below the horizontal asymptote? So this is where we're going to use tools, right? We're going to do this in a smart way. So I'm going to switch over here to Desmos, and we're going to input this equation, this function, and be able to see exactly what the graph looks like. All right, so I'm in the Desmos now. So I'm going to enter in that equation. Here's how I'm going to type it. Y equals, right? And then we have x plus 3 in the numerator. Now notice it'll start to try and graph what we've typed in, but we're not done yet. And then divide, and then remember we had 2 binomials. The first one was x minus 1, and then the second is x minus 5. All right, so now that we have that entered, hey, look what we have here. Right, let me zoom out a little bit here. It looks like our 3 branches. And do you remember where the asymptotes were? Let's actually sketch them in here. Let's see, I'll do this in blue. So remember we had a vertical at x equals 1. That would be right here, okay? And we also have a vertical at x equals 5. That would be right here. Probably a dashed line would be better, but I'm not going to try and draw that here. And then we had 1 horizontal asymptote, right on the x-axis. And we can see that those asymptotes, right, agree with the branches that we had. Right? So let's go back to, let's see, I guess I should clear these asymptotes I put on here. And let's go back to the, hopefully I can go back here. Yeah, we'll just close this out. And let's go back to the last slide here, right? So we can then sketch in those 3 branches, right? We saw the 2 branches above the horizontal asymptote to the left and to the right, and then the 1 branch in the center was below. Okay, so I'm not gonna, spend a lot of time trying to very tediously try and create these graphs, but rather find both the vertical and horizontal asymptotes, and then use Desmos to plug in your function and confirm that, yep, that's where my asymptotes are, and now I can see where those branches are. Okay, so That's it for the lesson. We already know how to find the vertical asymptotes and holes. In this lesson, we've been able to now identify the horizontal asymptotes, right? It's going to be one of those three cases. And we now know how to do all those together, find both vertical and horizontal, and then use a tool like Desmos to help us understand what the graph looks like. All right, that's it.